Hello and welcome to Introduction to Unity Games Development Part 7. In this session, we will learn the available monobehavior list of functions in a monobehavior class. Transform position function, what is difference between awake and start function, what is difference between update and fixed update function. So let's get started now. We worked in the previous section that how to create a script and how to attach this script to a sphere game object, and we have seen what are the different key events. So if we press different keys, how it is going to behave. Now in this case, in this session, we will be creating a new game object. It could be a cube, it depends upon you, whatever you want. So we will drop a cube object, we will create a new C# script, we will attach this C# script to this newly created cube, and then we will understand the behavior of different functions, and we will understand the transform position component with this game object. Let's start now. So let me just go and create a new game object here. So you will right click in the hierarchy view, right click here, 3D objects, and this time I'm going to create a cube. See, the cube is placed on top. I'm not changing this position, so only I'm just moving it little bit far from the camera so that you can see here. So the cube is placed over here. Now we will be creating a script and we will attach this script to the cube. So we will go to the script folder, right click in the script folder, create, call it create a new C# script. So I'm going to call this script as cube, press enter. See, the C# script is created. Let's attach this script to the cube. So you can drag and drop this script to the cube game object. See, the script has been attached to the cube game object. You can see over here. Double click on the script, open it in Visual Studio and make changes. So here is the script, and within this script, first of all, we will learn the transform position function in C# script. So this, as you are aware that this script has been attached to cube game object, now what we can do in order to get the position of this cube game object, we can use the transform function here. So I'm going to use this transform function. So debug debug.log position of cube on x-axis So to get the position of this cube on x-axis, we use transform dot position dot x. So this is going to return us x-axis position of this cube. Similarly, we will be adding couple of more lines over here, lines of code, and we will be displaying the position of y-axis and z-axis. So position of cube on y-axis, transform dot position dot y. So you can see these are the available components x, y and z. Let me end with semicolon. Let's insert the last line here, debug.log position of cube on z-axis is going to be transform dot position dot z. So this is going to return me the z-axis position as well. So let's save this script and head back to Unity and run this game. See, the game is running. See, the game is running, and if I go to the console window, it is giving me a fixed position of x, y, and z axis. Right now, if you see, the x-axis position is 3.67, y-axis position is 3.003, and z-axis is minus 0.8. Now, the reason is, if you see this cube, if I select this cube here, in the inspector window, you can also see these positions. These are the same positions which we are getting over here. So if I change this position of y-axis over here, you will see the effect in the console also. The reason being is you need to scroll down because there's a long list of displaying these messages. That's why we cannot see the latest one. So if you see right now, it is 3.44. When we change this position should reflect in the console. But to get a better idea, let me go back to the game window, and if you can see in the status bar, the position of cube on y-axis is 2.94, which is current. Now if I change this z-axis position, see the position of this cube on z-axis is 1.46, which is again current. Similarly, if I change this x-axis position, see the x-axis position is also updated. So using this transform game component, we can get the positions of different game objects. We can move up and down, we can move right and left using this transform dot position game object, or using this transform dot position functions. Suppose I want to display a message that if the y-axis reaches to a particular number, then it should display me a message. Now in that case, I'm going to insert an if condition here. If transform dot position dot y, if it is less than or equals to 5f, if it is the y value is very you can say is if it is less than 5, okay, then what I want to display, I want to display a message over here, debug.log, I am about to touch the plane. This message I want to display if the value, if the position is less than 5, then this error, this message, it's not an error message, this message will be displayed. So let me just save this, head back to Unity. Now before playing this game, make sure the position on y-axis for this cube game object, it should be more than 5. Right now the y object is 3.03. Let me move it up. So it is, let me just zoom out as well a little bit. So if I move it up, so right now if you see, the position on y-axis for this cube is 6.63. Now what we want to do, let's play this game. and once the game is playing, so if you move it down, you just concentrate on this status bar, you will see this message that we are going to touch the surface. So if I move it down, it's 4.47. so let's check the console and see the output. See, we are getting this message, I'm about to touch the plane. So this got triggered automatically when we reach to a certain y-axis position. Let me stop this and head back to now. At this point, you must be aware of the use of this transform.position.x. What is the use of it? In order to get the x, y, and z values, we can use this transform.position function. It is similar to if you go to the Unity and select this cube, here you will see the transform component and the position component, which has x, y, and z values. So it's very simple. If you understand this logic, then accessing any other type of component for a particular game object will become easy for you. Now, as we mentioned that there are different mono behavior class functions. Only these two functions are right now shown whenever you create a C# script, which is start and update. There are many other functions also in the background which we can activate and we can show. So if you press Ctrl Shift M, that's the shortcut key. So once you press Ctrl Shift M, this is going to show you the list of available functions which can be part of this mono behavior class. Now if you see, we have awake function, we have fixed awake, fixed update, awake, late update function, on animator, IK, and the list goes on, as you can see over here. So I'm going to add awake and fixed update functions over here. I'm going to activate them as I'm going to use them in my class. If you click OK, you will see the awake function and the fixed update function. Now the sequence of these functions, how it is going to be called, let me put it into a sequence. Control X to cut, and I'm going to place it before the start. Now that's the sequence. Now remember, the awake function will be called first and then the start method will be called. Now awake function will be called only once, similar to start function. So remember about this awake function. Awake function is called first even if your game object is disabled. This is good to set some initial preferences or settings. Start function will call, or the start function will be called only once. The start function will be called once your program loads, or once your game loads, or once you start your game. At that time the start function will be called. So you cannot repeat these functions by simply enabling or disabling the game objects. Now the difference between update and fixed update function. So starting with the update function here, update function will be called in every frame as we discussed in our last session. So if your computer speed is 30 frames per second, so this update function will be called 30 frames per second. So update function is useful for regular updates like moving non-physics objects in your game, or if you are creating a simple timers, or if you are receiving inputs from the user like pressing any key, or if you are creating the mobile game and you are changing the mobile direction up and down, left and right, then this update function will be very useful to program such events. Here in update function, the time interval varies. Now in fixed update here, in the fixed update function, it is going to be called on every physics steps. Fixed updates interval are consistent and it is used for regular updates. Remember, so the fixed update is going to be called on regular updates actually, and the interval is also fixed. So let's see. So we will be printing some messages in fixed update and update function, and we will see how it responds. So we will be implementing some logic in fixed update and update function, and we will understand how these two functions behaves. Now in the fixed update function, I'm going to display one message over here, debug.log fixed update function colon this. Now here I'm going to use time.delta time. The time.delta time function will work on intervals in seconds from the last frame to the current frame. So this difference is it is going to generate and it is going to work on. So simply if I go and put one more line over here, debug.log, this is update function only, plus time.delta time. So let me save this, add back to Unity, and let's play this game. See, the update function is being called in every frame, in every seconds. Let's check the fixed update. As you can see over here, the fixed update function was called here, again over here, with the sequence, with the proper interval. But if you see the update function, this is being called based on the frames actually, and you can see in the status bar also. So that's the difference between update and fixed update function. So remember, fixed update function is called on regular intervals, whereas update function is called based on the frame rate. Let me stop this and open up Visual Studio Editor, and let's understand the difference between awake and start functions also. Let me call this line of code in the awake function, debug.log awake function is called here. Let me copy this line of code for a quick action. So this time we will just update this to start function. Start function is called here. So if I save it, let's go to the Unity and run our project. If I activate the console window, and let's see the awake and the start function. Look at this. The awake function was called first, and then the start function was called. As I have a couple of debug statements in the start function, that's why it is being called. Actually, the reason is as you can see, we have a move script and we have cube script. In the move script, you remember last time we added this debug.log statement. If I open this move script, I can show you there is another debug.log statement in the move script. That's why that is being called as well. So if I open this move script, so this statement is also being called over here. That's why I'm getting to start inputs over here. That's why I'm getting two start messages over here. So if I scroll down, then you can see the fixed updates, and if you scroll down fixed update, then the update function will be called. After this fixed update function is being called. So in this session we learned the different mono behavior functions, which includes but not limited to awake function, start function, fixed update and update function. Then we understood the transform position function, how to get the position value on x-axis, y-axis and z-axis, and to display them in Unity game. So practice these things and I'll see you in the next video.